Hey everybody. Thank you for attending this talk. I'm here to try to convince you that IoT can be fun if you use a high-level language, such as Micropython. So my name is Sebastian Roll. I work at a company called Whitson. That's my day job. And on the side, I have co-founded a company called ByteBarista. So if you'll indulge us, my team has created a video to show how far we've come. Okay. Do we really have a lab at ByteBarista? The answer is no. So what you saw here, we made after work yesterday, just for this occasion, actually. What I did was I went to YouTube and tried to find some corporate music. They have an MP3 file. I think the third hit there was perfect. And after that, I needed to edit. So I've done one video edit in my life before for a vacation, and I used my girlfriend's Mac. But I don't have a Mac, so I found this open source program called KDN Live. And I went to storyblocks.com and got a subscription. It's $39 for 1 month. I went to Fiverr because I wanted to have some narration. I found this deep voice. But it was a little bit too expensive, and also there was no time. So this is us. This is ByteBarista. We're just three pals, three friends. We formed a company because we thought that if we have a company, we don't have to pay value-added tax, which is not true, not for us yet, because you need to have a certain level of income before that is the case. It's me, and it's Hans Elias Josefsen in the middle, and then it's Morten Dille, and the dog. He's the one who comes up with all the good ideas. The reason for showing this video was to get to what you're able to do now if you don't, even if you're not a specialist in the field, just because things are so available for us. The last thing that we did was a project. Actually, Hans does this alone. He read a research article about indicating that we might be able to, that our brain might be able to sense the magnetic field of the Earth, because they changed the magnetic field in the experiment, and they noticed a difference in the brain waves pattern. So, of course, he has built a box. This is what his apartment looks like right now. So he wants to generate a magnetic field, and he has an Xbox controller, and he wants to set the magnetic field randomly, and then he has to guess. So he's trying to train himself to become a pigeon, I think. If you notice the toilet paper rolls at the bottom there, it's so that his head is in the middle of this box. That's how it's supposed to work. So A microcontroller. What is a microcontroller? A microcontroller is kind of like a small computer. It does not have a very fast CPU. It does not have a lot of memory. I think the distinguishing feature between a regular laptop and a microcontroller is that a microcontroller is designed to do one thing, one specific particular thing. And that one thing might be to run your code that you put on it. So it's not running a full operating system. It's running either directly running your code, bare metal, or it's running something like a real-time operating system. But it has one purpose. Why would you use a microcontroller? Well, it's cheaper. There's the Raspberry Pi, you can see, the Zero, a very small one. A microcontroller is usually even cheaper than that one. It spends less power, so you can connect the battery to it and put it away in your apartment and have it sense things for you. The boot up time is less than a second, usually, compared to, I don't know if you have a Pi Zero, it takes a long time to boot up this Linux operating system. Yeah, and it doesn't have this Linux or Windows, so you have much more control over the scheduler, for example. So can IoT be fun? For me, I peaked at IoT at the Arduino when Arduino got popular. But for me, it didn't really it didn't really vibe with me. I felt that the payoff was not there. So there was maybe a blinking LED, maybe some capacitors, some resistors, but I never was interested in it. So now, things with high-level languages, I'm super interested in it. And for me, my flavor is Micropython. You might be a JavaScript guy. Then you have a different language. I think it's called Esp. So Micropython was written in C by a guy called Damien George. And it's meant to fit the language specification of Python 3.5. It also has the async await syntax that you find in 3.6, which is very useful. What you do is you flash your microcontroller once with Micropython, and then after that, you simply move files, Python files to it. Or you can program code directly onto the microcontroller using a USB cable. So what it does is, when in your main program, if you import a module that's on the microcontroller, then it compiles the script or the module into bytecode, and that is run by the virtual machine in there. Here's a list of officially supported boards and architectures. I can mention the first one, PyBoard. That's the reference architecture for Micropython. I would recommend that you support them by buying the PyBoard. They have a new version available. Micropython is designed to run on a minimum of 8 Ks of RAM and 128 Ks of ROM. I can also mention the ESP32. That's the one I've been using mainly, and that's the one you'll see during this session as well. It has Wi-Fi and it has Bluetooth low energy. It has 4 megabytes of ROM, half a megabyte of RAM, and a dual-core 240 megahertz processor. So it's pretty powerful. So IoT is fun. IoT is fun when you can do lots of things with low effort, for example. That's one thing I like about it. Python is notorious for you being able to do crazy things even at the start of your learning curve. Here, as an example, it's a Reddit post from a year ago. A guy wrote a Python script to take a JPEG, an image, and convert it into ASCII image. And people were interested. They said, "Can I please have a look at your code? Can you share the code?" And sure enough, he shared the code on a post following day by taking a picture of it. So he took a picture of his screen and shared that. So I think that tells a lot about how powerful a high-level language like Python can be. You don't even need to know about pastebin or anything like that. Step by step, if you want Micropython on your controller, you connect the device. Here's an ESP32 microcontroller. So you connect the device, and then you go to micropython.com/org/downloads. You get the binary from there, and then you flash it. And after that, you connect through a serial prompt terminal over this USB cable. So we can have a look. micropython.com/org/download. So here we can see the ESP32. And here's a list of some. I would just go for the generic or the generic SPI RAM if you have extra RAM on your ESP32. So you need a tool called Esp Tool, and that is a pip installable tool. You just write pip install Esp Tool, and you get it. So the first thing you do is you erase the flash, and then you run this command to put this downloaded binary onto the device. So I'm not going to do that. It doesn't take more than a minute at most. But we'll go through the language and how it feels like. So here I have PycoCom is my preferred terminal program. So I just specify the device and a baud rate. So now I'm connected to this microcontroller right here. So let's see if we can run some code. One thing special about Micropython that regular Python does not have is the machine module. And the machine module will have all the classes that you need to interface with components like sensors, like input components, and also to give signals out of the microcontroller. So we're going to import pin here, and we're going to instantiate the pin class with a pin number. This pin number here would be connected to a green LED on the microcontroller, on this particular one. And we're going to try to turn it on, give it a value of 1. So as you can see, it's now glowing a nice green hue. So we already got really far. You can also now, let's see if I can put it, you can do LED.value 0. And I hope it turned off. So what more can you do? You can use something called pulse width modulation. Who here has heard about that concept? Yeah, about half. So you turn this pin up and down really fast, or you can decide the frequency of the cycle. So say a frequency of 2, then it goes up and down twice in a second. And the duty is for an up cycle, how long do you want it to be up? So if it's 50, that would be 50%. Then it's up half the time and down half the time. So let's have a look. So we, instead of making just a regular pin, we pass it to a PWM class. So now, let's see. Now we can specify frequency. Let's say 2. LED dot, make it bigger for you. Duty. And let's make that 50. Oh. Try again. Did I do the same mistake again now? LED fric. Is it blinking? Oh, happy to know that. So you can change the frequency of the blinking. Say we change it to 10. It's blinking pretty fast. Let's do 100. So now you're not able to see that it's blinking up and down. So in effect, you're creating a signal somewhere between full and on and off. So you can use pulse width modulation to emulate an analog signal. So if you want the LED to be just a little bit bright, that's how you can do it. I also want to show you, just like regular Python, import OS. It has a file system, list dir, and you get the files there on there. It has a garbage collector, import GC, which is automatically run, I think, when the heap is 75% filled up. But you can set that threshold, and you can also manually do a garbage collection like this. Okay, so I found this. Let's see. This is from a forum, Nordic Semiconductors. The question is it possible to program something with Python instead of C language? And the answer is, they're fine to mess around with if anyone has time for that, but if you're asking about them, that likely means you're looking for a way to avoid learning C. And with microcontrollers, I have to tell you, that's going to hurt you quickly. And then he writes, I like Python, I like microcontrollers, I'd never combine them. And I can understand that sentiment. I think it's really weird for someone in the industry, some embedded developers, to think about a high-level language. There's no, why would you even do that? But I would argue that there is a room for it. This is from 2019, the Stack Overflow survey. It shows the most loved language, where Python is at the top, and C makes the list there at the bottom. And the most dreaded language, where C is number 4, and Python is not on the list. So all I want to say about that is that there are Python developers who would rather not like to learn C, and that's fine, that's okay if you don't want to do that. But you should still be allowed to play around with microcontrollers and make some cool things with it. Micropython is being used in the industry already, so there are use cases for it. It's probably very good for prototyping, for getting to market really fast, and other reasons, I'm sure. But these presentations here are much better at giving a list of how it's used than I am. But I will show you one use case. An acquaintance of mine, he came to me one day and he said, there's an NGO in Sierra Leone. I'm going there to meet my family. And this NGO, they really want to be able to know the level, the water level in some tanks. There are tanks spread around with water, and they're not able to tell when the water is out before it's too late and people can't get water anymore. So they would like a cheap way to be notified when the water is running low in these tanks. So I had a microcontroller, I had a battery pack, and of course I buy things online that I don't need sometimes. So I had this binary sensor there, which is almost like, it's like a balloon on a rod, and when you put it down in water, the balloon goes up, it floats. So it emits a signal of 0, for example. And when the water level reaches below this sensor, the balloon goes down, and there's a magnet inside, so it knows which state it's in. So then it changes state. It's a binary sensor from 0 to 1. So we figured, what if you just make some quick code? He had a couple of days before he was leaving. We start out by booting our device. Then we check if this water sensor indicates that the water is low. If it's not, then go to deep sleep and survive on minimum battery consumption. And wake up when you find that a sensor has been toggled. And when you wake up from deep sleep, you automatically go into boot mode again. It will then check if the water is low. Yes, the water is low. Then connect to the internet with Wi-Fi and send an SMS using an API call. And after that, go to deep sleep and wait for a toggle again. So we tried to solve that problem. Here is a better picture of this sensor and how it would work. And here is the implementation in Micropython. So you have 3 files here. Let's have a look at the settings file first. So here you can see Which pin is the binary sensor connected to? Pin 4. What is the Wi-Fi SSID and password? Some information that you need to send this call, API call. What is the recipient's number, telephone number? What is the ID of the tank? And lastly, what is the text you want to send? Now in Micropython, there are two special file names. So two file names that are treated differently than everyone else. The first one is boot.py. This will run at boot up immediately, even before it establishes a connection through the USB. And after that is your main program, main.py. This is where you put your master code. And you can import other modules from main.py, but these will be run. So let's have a look at boot.py. Here you can put whatever you want, maybe some utility functionality. So from machine, we import the real-time clock and deep sleep, also time. You notice that Micropython has many of the same modules as regular Python, but with a U in front of it. So U requests might be familiar to you guys. So we make a function that connects to the Wi-Fi with the back off here. If it's not connected, you try again. So after that, you have a function to do the API call. So you use uRequest to do a post call. And then there's a function to do deep sleep, which takes the floater pin object as an argument and sets it to wake up when the floater is toggled, or 0, I don't remember, and then do a deep sleep. And lastly, the main module here. What that does is it instantiates the floating pin, sets it to be an input pin. And if the value is 0, that means the water is low. So we try to connect to the Wi-Fi, and then we try to send this post request. And here you have some lacking exception handling that you could add if you wanted. And if not, if water level is fine, then go to deep sleep. So we were able to make this thing. We even had time to laser cut a little case for it. We made 2 of them, and he brought them to the NGO who had some researchers. And it's also cool because Python is a very accessible language for them as well, so they could look at the source code and understand it. You have some concepts when you talk about hardware and IoT. Who here has heard about all these concepts? So maybe a 4th. So what I would like to say is that don't be discouraged by all these new concepts. In reality, they're not so difficult. They're just some new words. It's also nice if you have your favorite familiar language to kind of compartmentalize your learning curve so that you don't have to learn a new language in addition to all this new stuff. For serial communication, you bought a sensor at AliExpress and you want to connect to it. So mostly what you're going to be using are one of 2 protocols. The first one is SPI, and the second one is I2C. So you can see the I2C, the bottom one, has 1 pin, a clock pin, that's the SCL, 1 clock pin that just goes up and down at a speed, and then a data pin, which sends the data synchronized. So you can see that for the I2C, you can have multiple components on the same 2 pins, 2 wires. Here's an example of how you instantiate an I2C object in Micropython. And then usually, the component that you bought will probably have a driver somewhere that someone has made. It's going to be written in Python, so it's just a class. And that class will accept an I2C object in its constructor. That's normally how it goes. This is a Bosch environment sensor called BME280. So this will help you read temperature, humidity, and pressure. And you can either buy this sensor just as is, you see there on the top left. And the sensor also has a data sheet. And in the data sheet, you'll find something called typical application circuit, or something similar to that. So you can design a small printed circuit board and assemble it yourself. But what you would normally do at the start is you would just buy a module. So someone else has designed it and printed it, and that's what you see on the right there. So then you can just buy it and connect it to your microcontroller using wires. This module here accepts both I2C and SPI, so you can choose. If you decide to go the route with component modules, with the modules themselves, then it's a great way to get started. We had a workshop where we built some boxes, and we ended up, it looks good on the outside, it does not look so good on the inside. So you can see the microcontroller is connected to the left there on a white breadboard, and it's just a complete mess. And if something goes loose, it's very difficult to deal with it. So then the next step would be to make something like a printed circuit board. So this is something we built from the experience of the workshops, that it's too much for people to learn to connect things and to learn how to code. It's best if you can teach them one thing at a time, because that makes it much, much easier to debug when you have a problem. So we built this, we call it the pad. It has a speaker and a microphone. It has a touch display in the middle. At the bottom left, you can see the environment sensor. That would be the BME280. Also, it has some input devices, some buttons, an analog direction, a micro SD memory card, and let's see, some LEDs on the right, and a motion sensor. So it has a 9-axis motion sensor it can detect. So if we have a look at that one, okay. So what we did is we designed the PCB so you can connect all the components on the top. That makes it much easier to assemble. And then we have the microcontroller itself. You just plug it in from the back. So let's see what we can do. The first thing is the microcontroller itself has a button here. So we can try to instantiate the pin as an input device. So now we connect it to it, and then import the pin class, instantiate it, and also check the value. Button.value is 1. Button.value, if you hold the button down, let's hope that it's 0. That's great. Okay, so what if you want to interrupt your code? Well, first, we'll have a look at the I2C. We'll instantiate the BME280 class, and we'll try to read the values, do a read. So I know that the clock pin is supposed to be 27, and the data pin is 32. So I hope you're just going to have to believe me. So BME values will give you this string here, or it's a tuple. BME values. So now you have a thermometer. That's great. You can do interrupts like this. So say you have a loop here that if you have a flag set to true, then read the values from the sensor, and then set the flag back to false. Then you can have a callback function called button pressed, for example, which sets that flag to true. And on the button class that we instantiated, there's a method called IRQ, where you can set it to trigger on button being pressed, I think. So you can do a falling or rising edge. And then you specify the callback function. So let's just copy paste this thing in. And hope that when we now press the button, it does a reading. So that's how you can use interrupt handlers. Okay. Let's go. We've done the OS and list there. So can we do something more exciting with this thing here? Let's see. So I'll show you the GitHub repository. The design itself is open source. You can build it yourself if you want. This is the GitHub repo for the source code that you can have that has drivers and everything. And how you can install it is that you can connect to Wi-Fi, and you can, while you're connected to the microcontroller, you can use upip and upip install Micropython the pad. And you'll have all of these Python files downloaded over Wi-Fi directly to your device, which is really nice. Okay, so what we'll try to do is we're running a demo, so I can tell you that the pad here has a folder called demos with a bunch of demos. And what we did now is that we are checking out the LED control demo. So this is just to show that, let's see, it is a touch display, so you can slide here and you can adjust the LEDs that you see, and you can also lock the color of each of the LEDs, and then you can make new ones. So that's a little bit fun. So it is connected to the Wi-Fi, so if you wanted to control the lighting in your house, you're welcome to do that. Let's go one step further. There's a Tetris clone. And this is all written in Micropython. And it's very, very difficult to play this game with when everything is kind of mirrored. But it seems to work okay this time. Much better than last time. So if you want to break your code, you just do Control-C. That's another one of a nice feature. So why don't we go crazy? So between my previous conference, which was maybe a week ago, 2 weeks ago, and this, Morten, he created this demo that really blew me away, and he showed it to me, I think, the day before yesterday. And if it works, I would like to show it to you. Still everything in Micropython, and he is not even a developer. He's a PhD doing biotech. So he just codes on the side. But he's very good, of course. So he made something called Zelba. So what would Zelba be? Okay. Look at this. So you walk around, you defeat some enemies. It's not really easy to see. If you want to have a look at it afterwards, you can do that. Let us try to show you just really quickly. So he did borrow some sprites from Zelda, the Game Boy version. yeah, so to show, I think it's mostly to show, mostly to have fun, of course. But it's also to show what you can do with this device. We attended a conference where we had a workshop this summer, a 3-day workshop, and people were very excited to try it. We had a poster session, and by popular request, we did a full-day sprint at the last day. So people are really excited to learn embedded programming if you're not really an embedded developer. So that's cool. Maybe lastly, I want to show you something that you can make, or at least that I did for my employer, because at stands you want to attract people. So we made a music game. So the idea here is that you listen to music and you need to tap the edges like Guitar Hero when the light comes to the edge. And of course he has a friend that is trying to not help him succeed. Yeah, I think he has experience in blocking his friend out. So this is how that came to be. We found a table outside of our hackerspace, and we decided to borrow something from that and fit it with LEDs. And we made a proto board, is what they call it, something between a PCB and a breadboard. And here I can show you a little bit about where does Micropython, what are the edges in terms of performance. So yeah, you can blink things. We put acrylic plate, and it looks even cooler. But if we try to do animations, then we notice that, okay, now we need to start optimizing our code if we're going to keep using Micropython. So Micropython just vanilla is maybe 100 times slower than C, but you can do plenty of things to optimize it. Here's the requirement spec. So that's what we needed to actually have in place. And the code itself was coded on the train ride to the conference the day before. And it doesn't look good. It's not beautiful code, but it actually worked. And I would never been able to do it in C myself. Yeah, so why and when should you try out Micropython? If you're already an embedded guy, you can try to evaluate it, try to put it on as an extra tool in your tool belt for rapid prototyping, for new ideas. And for everyone else, it's just really exciting to have things, physical things, do things for you, using a language that you love. And for optimization, the Damien George has a good video on that, where he has an LED that blinks from 57,000 blinks a second to 27,000. So I think that's a 500 multiplier performance boost, still within the Micropython framework. And that's it. We have a website, bytebarista.com, where if you're interested in learning more about how we built the PCB, how we built this Rith game, if you want to contact us, there's information there. And I hope to see you at the next Micropython conference. Thank you.